this equation. Next, ang kailangan natin ng mga values, itong displacements, which are U1, V1, theta 1. Ito na yon. And then we have U2, V2, theta 2. Ito rin iyon. And then, kailangan din natin yung length, capital L. Ito. Direction cosines, small m, small l, and the beta factor. Okay, so, let's do that. Tatabi ko lang ito. Kapag i-move nyo ang equation, make sure that you cut the whole text, like this. Control X, tapos pag meron kayong paglilipatan, make sure na walang nakapatong na equation dun sa cell na paglilipatan ninyo. Yan. Okay, so next, sasolvin ko ngayon itong 6U1M all over L. Okay, so open parenthesis and then open parenthesis ulit. 6 times U1 times M all over L, capital L, minus 6 times V1 times small l all over capital L, plus 4 plus beta, close parenthesis, times theta 1, and then minus, dito na ako ngayon, open 6 times U2 times small m divided by capital L, plus 6 times V2 times L divided by capital L, plus the quantity 2 minus beta factor, close, times theta 2, then close. Next is multiply ko itong dalawa. Yan. Okay? So, yan ang equation para makuha itong M1. See? So, that is 120. That means tama yung equation natin. Okay? Ngayon, take note na itong 8400 na yan, ito yun. Tapos yung 0.01429, ito yun, nasa loob ng bracket. Ngayon, pag pinag-multiply mo na yan, that is your M1 in terms of kilonewton meter. Okay, so, ang gagawin ko, I will copy this equation. Paste it here. Also copy this equation. Okay, and then, pag multiplyin ko na silang dalawa, ayan, tanggalin ko lang itong equal sign, and then copy this full equation again, dito ko na ipe-paste, ayan, okay, so that is 120, and then I can delete this. Next, sasolve naman natin ngayon itong M2. Okay, so let's say delete ko yan. Gagawa ko ng bagong equation. Ito ngayon ang para sa M2. Now, what are the similarities between M1 and M2? Okay, meron silang parehas na EI all over L over 1 plus beta. And then 6UI M all over capital L, parehas. Dito sila nagkaiba ngayon sa 2 minus beta. Okay? Dito sa M1, 4 plus beta. And then, yung 4 plus beta, nag-iba rin. Okay? So, we can just copy this equation. Then, i-trace natin kung ano yung mga papalitan natin. So, unang-una, etong 4 plus beta, gagawin nating 2 minus beta. Okay? Ayan. So, si 4 plus beta, eto, gagawin natin siyang 2 minus beta. Next is etong 2 minus beta sa huli, gagawin naman natin 4 plus beta. Okay? So, nasa huli yan. Ayan, gagawin natin siyang 4 plus beta. Okay, so minus 66.19. Let's check. Ayan, tama, correct. So now I will cut this equation and then paste it here. Now, all I have to do is, since natapos na natin yung paglagay ng displacements dito, I will just copy this, paste it here, or paste it sa lahat. Yan. Okay? Next is, ano naman itong force na yan? Take note na actually rigid. Okay? That means wala tayong displacement sa vertical. Okay? Wala tayong V displacement. Kaya that means walang force nag-move pataas pababa, di ba? So, F is equal to 0. Likewise, ang displacement mo sa horizontal is equal to 0. In the sense na, let's take a single member. Okay? Yang member 2. Di ba? Siyempre, merong displacement sa point 2 tsaka sa point 5. Pero, take note na ang displacement nilang pareho ay D4 and D4. Ang net displacement nila is 0. And take note na ang extension sa Hooke's law, ang force na nagkokos ng displacement or net extension is also the net force. Okay? Kaya 0 ang actual force. Anyway, pakita ko lang kung paano nakuha yung force na yan. Dito naman sa actual force, this is 0, but kunin natin yung equation dito sa truss. Yan. Okay, so element stiffness matrix for 2D pin jointed structures. Ito yung actual force F. Take note that this is the stiffness K multiplied by the net extension. Kapag sinabi mong net extension, that is D2 minus D1. Okay? Ngayon, ito yung equation. This is from truss. Ayan. Ito yung D2 and then this is the D1. Okay? So, in short, F is equal to this equation, AL over L times the quantity U2 minus U1 times small l plus V2 minus V1 times M, which is this. Now, let's try doing that. So, ang kailangan natin dito yung area, elasticity, length, and then the displacements, and then the direction cosines. Okay, so first, let's compute the AE all over L. So, area times E all over length. That's it. Then, multiplied by U2 minus U1 times small l plus V2, ito, minus V1, click mo yan, times M. And then, close parentheses. Okay, so that is 0. Now, all we have to do is to copy that equation, paste ko dito sa force. And then, pwede ko nang i-paste yan dyan. Okay, so that's it. Yung moments na ito, these are the moments due to displacements. Okay? Hindi pa yan yung final bending moment. Okay? Ngayon, yung final bending moment, isasali na natin yung fixed end moments due to loads. Okay? So, let's say, I will copy this muna. Pakita ko lang dito sa first page. Okay, so ito yon. Yan yung ginawa ko kanina. Yan. So, this is M1 and M2 moments due to displacements. Kumuha ko ng panibagong table. Ito yon. Okay, so yan yellow. Yan yung fixed end moments due to that are the moments due to displacements. Tapos itong pula, yan yung mga moments due to fixed end moments, yung galing sa loads. So, uulitin natin yung solution ng fixed end moments na natapos natin before. Dito tayo ngayon sa element 1. Okay? Sa start node, dito sa point 1, and then yung end node dito sa node 2. Remember na ang fixed end moment, that is WL squared all over 12. So, ang W natin ay 40 times 36. Okay? The length of this member is 6. Okay? Divided by 12. So, 120. And then at point 1, the direction of the moment due to this load is counterclockwise. Kaya gagawin natin itong negative. Okay? So, eto yon. Next. So, gawin ko na yung yellow. Dito naman sa kabila, sa end node here, syempre ang moment, fixed end moment dito, 120 rin. Pero, it is now clockwise direction. Kaya magiging positive siya. Okay? Ito yon. Okay? So, nilink ko lang dito, minultiply ko siya ng negative. Or, you can just copy this. Yan, 120. Next, punta tayo ngayon sa element 2. Dito naman. Moment dyan is 50 times 16 divided by 12. So, 66.67. Ngayon, dito sa node 2, it is counterclockwise, kaya negative siya. Ito. And then, sa kabila, magiging clockwise naman. Kaya, positive siya rito. Okay? Next, dito tayo ngayon sa element 3. Sa element 3, take note, wala tayong load. Okay? Kaya ang fixed end moment niya ay 0. Okay? Take note, fixed end moments, yan yung mga external loads natin. Okay? Next, dito tayo ngayon sa member 6 or member 4 muna tayo. Again, sa member 4, wala tayong load. Kaya, 0 rin ang kanyang fixed end moment. Sa member 5, 0 pa rin. Pero finally, sa member 6, meron siyang moment. Fixed end moment. Ngayon, dito tayo sa start node. Siyempre, ang direction ng fixed end moment dyan ay counterclockwise. And its value is PL all over 8. Okay? So, let's try. At 200 times the length of 4 divided by 8, kaya siya naging 100. And then it is counterclockwise, kaya siya naging negative 100. Okay? And then, dito sa kabila, magiging positive. Yan. Dahil clockwise direction siya. Okay, so markahan ko lang ito ng yellow, ibig sabihin na explain ko na yan. Next is you just add them. So this is negative 120 plus 120. Yan ang value ng moment. Ito ngayon yung final bending moment. Likewise, you just add these two again. That is also the final bending moment. Okay, now we just copy that. Oops. Paste mo dyan. Paste it here. And that is our final bending moments. Okay, yung final bending moments na ito, ang i-compare natin sa staad output. Okay? Ayan, kinulayan ko siya ng green. Now, let us draw the bending moment diagram. So, ito yung ating original figure, or this is our figure given, ano? So, member 1, member 2, member 3, member 4, member 5, and then member 6. I-incorporate na natin yung bending moment diagram. So, since dito sa member 1, uniformly loaded yan, ang curve natin is curve. Okay? Di siya linear. Magiging linear lang ang bending moment mo kapag concentrated load ka. Okay, so, yung 153.1, hindi yan given. Hindi yan na-solve dito, no? Solvein mo niyan mano-mano. Yung green na yan, those are the end moments. Now, let's plot the bending moment for element 1. So, at start node, remember that this is the start node, the bending moment is 0. Ito. And then, yung bending moment sa end node, that is 53.81. Ito yon. Okay? Now, let's go to element 2. The start node, at start node, the bending moment is 53.81 also. Dito, yan. Note na ang kanyang load ay uniform, kaya curved din ang kanyang moment diagram. Tapos, sa end node is 212. Ayan siya, 212. Now, let's look at member 3. At start node for member 3, take note, ang start node ni member 3 ay itong node 4. So, 174.9. Yan ang kanyang moment. Tapos, sa end node naman, ang moment niya ay 212. Okay? So, take note na itong bending moment ay 212 kay member 3. Ang bending moment din at this node kay member 2 is also 212. So, ibig sabihin, tama yung ating solusyon. Ngayon, kung hindi magkaparehas ang bending moment niyan, there is something wrong. Now, let's look at number 4. Take note, this is summation moment equal to 0 at any point. Okay? Yan. Now, let's go to element 4. Dito, ang start node, the bending moment is 11.54 negative. Ito siya. Okay? And then, sa end node naman, 39.01. Ito. Yan. So, maliit lang ang bending moment. And then, sa element 5, dito, At start node, the bending moment is 203.87. Ayan siya. And then 210.5 dito sa end node. Now, let's look at number 6. Ito. Meron siyang concentrated load dito. Take note na ang moment diagram niya ay linear na dahil concentrated load yan. Okay? So, at start node, 135.89. And then at end node, 210.49. So, if you will notice na, parehas silang 210.49. So, summation moment at this joint is 0. So, tama yung ating solution again. Now, let's look at node 4. Dapat, yung 39.01 plus 135.9 would be equal to 174.9. So, let's check. 39.01 plus 135.89, that's equal to 174.9. Okay? So that's it. Ang next topic natin would be comparing these results with STAAD. Okay guys, so thank you for listening.